Hello and welcome to the Math Bender, everyone. I'm Adnan Zaidi, and in this section, we'll discuss sequence and series, geometric series. We already have established up till now that sequence are pattern progression, but series are some of those progression. So, whether it be arithmetic or geometric, but in this section, precisely, we'll talk about geometric series. Where it is, let's start. So, we already know that 1, 2, 4, 8, 16 and so on, it is a geometric progression. The reason being that every previous term is being multiplied with 2 to give you the next term. Or the same way, if I write it like this and so on, so this becomes the first term, second term, third term, fourth term and so on, but yet they are arranged, they're written down in a manner, it is called a geometric series. And in order to find the sum of the geometric series, what matters is the ratio. So let's say if in this progression I can see that the ratio r is equals to 2, the first term is equals to 1. So r is greater than 1, the sum of the progression becomes Sn is equals to a r to the power n minus 1 over r minus 1. The same way, if this r is less than 1, then the sum is equals to a 1 minus r to the power of n over 1 minus r. Note that the sum will never be negative, as in like in arithmetic progression, the sum had been there had been any situations where the sum was negative as well. Not in this scenario. So let's look at some of the questions and then we'll talk about it. So as you could see, the first one, 1 plus 2 plus 4 plus 8, you have to find the sum of first 8 terms. Let's make the data first. So data will be S8 is what you are to find. The first term is 1, the ratio is 2. And as you could see, the ratio, if it is 2, then Sn is equals to a r to the power n minus 1 over r minus 1. S8 is equals to replacing a with a r as 2 to the power of 8 minus 1 over 2 minus 1. Now 2 to the power of 8 is going to be 2 to the power 5 is 32, 6 is 64, then 128 and 256. Just to check. Yep. So S at 8 is equals to 256 minus 1 over 1, which is equals to 255. So if I add these first 8 terms until 8 terms, I'll see that the sum of those numbers is going to be 255. Let's look at another example here. So 32 plus 16 plus 8 plus up till 10 terms. Now in this, as you could see, if I take out a, which is equals to 32, ratio is 16 over 32, which is going to be 1 over 2 and less than 1. So I need to find out S10. And we know that Sn is equals to, in this scenario, it will be 1 minus r to the power of n over 1 minus r. And S10 is going to be, instead of a, I write 32 times 1 minus 1 over 2 to the power of 10 over 1 minus 1 over 2. And Let's write it down. So the sum of first 10 terms is going to be 1023 over 16. So looking at a question now, here, the first four terms of a GP are 1, 3, 9, and 27. So find the smallest number of terms that will give a sum greater than this number. Too many zeros though. So in this question, I'll first make the data A is equals to 1 and the ratio is 3. Every previous term is being multiplied with 3 to give you the next term. This is 27. So I need to find out n. How many terms will make a sum greater than this number? So Sn is equals to A, and since r is greater than 3, as I know, r to the power of n minus 1 over r minus 1. So 3 times r to the power, which is 3 to the power of n minus 1 over 3 minus 1 is greater than 2. So 1, 2, 3, 4, 5, 6. I'll just write 2 into 10 to the power 6. So now 3 to the power of n minus 1 is greater than over 2 is equals to 2 times 6. And I can say 3 times 3 to the power of n minus 1 is greater than 4 times, after multiplying this, 10 to the power of 6. So once I divide it, so 4, I'll write it as is. As you could see that there are 6 zeros which were there in the question, and so rather than writing all the zeros and making any mistake, it's better to use this 10 to the power divided by 3, which gives you 13,000, some 3 to the power of n minus 1 greater than 1 and 1, 2, 3, 5. So 1. Now 3 to the power n is greater than plus 1, adding 1 to it. Now, as you could see that here the variable is in power and I need to bring it down. Hence, the log comes into place. So if you remember in my previous logarithmic videos, you can check that whenever we have a variable in power and we need to bring it down, we apply logs. So I'll apply log base 3 both sides, and this will become now if I apply log to it, log base 3, and you see I just wrote answer over there, which means whatever the value that was there previously, I'm using that. I don't have to remember it. So 3 to the power, so this becomes n is greater than 12.84. Now, as it is clearly evident that n cannot be a decimal or a negative value, because n refers to which term are we talking about. N has to be a whole number and a positive one. So it means that the sum, which was 2 million, was attained at this value. So what is going to be the next term? So if we say if n is equals to going to be 13th term, the sum of those 13 terms will eventually be more than 2 million. That is the value portrayed. Let's look at an application-based question. A company producing salt from seawater changed to a new process. The amount of salt obtained each week increased by 2% of the amount obtained the preceding week. It is given that the first week after the change, the company obtained this much. So the first week, company obtained 8,000 kilograms of salt. The second week, it's going to be 2% of the salt. So what I'll do is, I'll take out 2% and add it. So 8,000 is 100%, and after adding 2%, it's x. It's going to be 8,160. The next week, they'll get this much amount of salt. So if I need to find out the ratio, so A is going to be 8,000 and ratio is 8160 over 8,000, which is going to be 1.02. Now find the amount of salt obtained in the 12th week. So by the start of the 12th week, so here part 1, A is 8,000, ratio is 1.02, n is 12, and u of n, because it's asking in the 12th week, it did not ask you for the sum of total salt received during all these weeks until the 12th week. So u of n is a or n minus 1. We already have talked about it in our previous lecture. So u of 12 is going to be 8,000 and ratio is 1.02 to the power. Instead of n, I'll use 12 minus 11. Which gives you 9946.9. In fact, it gives you 9947, rounding it off, kilograms of salt during the 12th week. Find the total amount of salt obtained in the first 12 weeks after the change. So the total amount of salt is like adding the whatever amount that you received in the first, then second, then third, then fourth, until the 12 weeks. So A here is 8,000, ratio is 1.02, n is again 12 because the amount is obtained during, not after the end of the week, but during the week. So if the salt was received under the condition that it was received after a week, then we would have looked at it differently. But in this scenario, the salt is received by the start of the first week. So which means by the start of the 12th week, they will receive the quota of 12 weeks as well. So u of n is equals to a or n. Okay. So s of n is a r to the power n minus 1 over r minus 1. I need to find S12 is equals to 8,000 to the 1.02 to the power 12 minus 1 over r is 1.02 minus 1. Just plugging it straight away in calculator will give you so the sum of total salt received until 12 weeks is 107,297 or 6.7. Just rounding it off to one decimal place. So let's look at another and the last question of the day. So a runner who's training for a long distance plans to run, and it is increasing until each day for until 21 days. And the first day the distance that is covered is x kilometers, so we don't know the exact quantity, but every day after this it is increasing at a rate of 10%, and on 21st day she ran 20 kilometers. So if I just have to write this series, I can write it like this. Day 1 is x, day 2, if it is increasing 10% from x, so it's going to be 1.1x, because 10% of x is 0.1x, and adding to the previous value, which makes it 1.1x. And until 21st day, which is 20 kilometers, that's what she ran. And we need to find the value of x according to the question. So since whenever you see there is a rate of percentage applied, it's clearly not going to be an arithmetic series, because no matter what, previous value multiplied with the 10% and an increase will actually target to the geometric progression or geometric series. So here a is equals to x, ratio is 1.1x over x, and x cancels out, hence the ratio is 1.1. And u of 21, 21st term, is 20 kilometers. So I'll play along. We know that u of n is equals to ar to the power n minus 1, and u of 21 is going to be ar to the power 21 minus 1, which turns out to be, instead of a I replace it with x, and instead of r I replace it with 1.1 to the power 20, and the term is 20. So 20 over 1.1 to the power of 20. Gives you 2.97. Since the answer has to be correct to one decimal place, and in this scenario, as you could see, that 2.97 will give you round off to 3. That will also be counted as one decimal place, because the value that is next to 2 is 9, 3. So I'll round it off to 3. That's the answer. Find the total distance she runs over the 21 days. So we are to find out S of 21 here. So Sn is equals to a, since ratio is bigger than 1, r to the power of n minus 1 over r minus 1, and S21 is going to be, since we have the value of x, which is 3, or a, which is the value of a as well, 1.1 to the power 21 minus 1 over 1.1 minus 1. So I'll straight away plug it in my calculator rather than further solving it here. So the total distance she ran during those 21 days is 192 kilometers. These are some of the example questions that I cater to geometric series and progression. If you have any questions, specific questions, you may write them down in the comments. I'll definitely put a video over it. I'll see you in my next session. Until then, take care. Bye.